reduction of alumina can be done. Okay, reduction cannot, that means aluminium cannot be reduced by some of the common reducing agents like carbon monoxide and hydrogen. Carbon monoxide and hydrogen. So it needs to be done by electrolytic reduction. So electrolytic reduction of fused alumina, HALL-HEROLT'S process. And these are some of the things we need for this process for reduction of alumina. So electrolytic cell is nothing but a container. This is a container. Okay, this is a container. This container where electrolysis can be performed is called electrolytic cell. This is electrolytic cell. That means electrolytic cell is a vessel in which electrolysis is done. So what is electrolytic cell? It is a vessel in which electrolysis is done. So for electrolysis of for the reduction of fused alumina, we need to take a special type of electrolytic cell. The design has to be somewhat different. So let's see, right? It is what it is. It is made up of iron. This electrolytic cell is made up of iron. It is iron tank. Okay. Oh, and what is the shape of the tank? Rectangular iron tank with a sloping bottom. It is a rectangular iron tank with a sloping bottom. You can see this. Here. This is rectangular iron tank. This is electrolytic cell. So this outer container, this is electrolytic cell. This is made up of iron. This is made up of iron. So this is rectangular. You can see this is rectangular tank made up of iron, and it has slope. This is sloping tank. Okay, this is slope. This slope is made. So why this slope is made? So that molten aluminium can be collected. If it is like this, it will not flow. But if it is slopy, then liquid can flow very easily. So it is designed in such a way that liquid alumina, molten aluminium will flow. So this is electrolytic cell. And the solution used here in the form of solvent, okay, electrolyte is So sloping bottom of the tank. The sloping bottom of the tank facilitates the removal of the molten alumina. So what is the function? Why there is sloping bottom in the tank? In order to remove molten aluminium. In order to remove molten aluminium, there is a sloping bottom. The bottom of this electrolytic cell is sloping. Why it is sloping? In order to remove molten aluminium. The tank is lined with gas carbon, and the tank is the tank that we have seen is lined with carbon. Then what is another thing we need for this process? That is electrolyte. So what is electrolyte? Electrolyte is the substance that conducts electricity during the process of electrolysis. Electrolyte is the substance that conducts electricity, is the solution that conducts electricity during the process of electrolysis. So for reduction of alumina, electrolyte is the mixture of molten alumina 20%, cryolite 60%, and fluorspar 20%. So electrolyte for reduction of alumina contains a mixture of alumina, cryolite, and fluorspar. So Alumina 20%, cryolite 60%. Why cryolite 60%? Because it enhances conductivity as well as it reduces the fusion temperature to 950 degrees Celsius. That's why cryolite is more. And fluorspar is also added. Fluorspar is also added, which is of 20%. And I'll be talking about the importance of this fluorspar in next slide. 20% that powdered coke is sprinkled over the surface of the electrolyte. Then another thing, powdered coke is sprinkled over the surface of the electrolyte. So what is the content of electrolyte? Alumina, cryolite, fluorspar, and then powdered coke, which is sprinkled over the surface of electrolyte. So what is the composition? 20%, 60%, 20%. That means if you convert it into the ratio, 20%, this is alumina, 60% cryolite, and 20% fluorspar. So if you divide all by 20, then you will be getting 1:3:1. So what is the, they may ask you what is the ratio of different substance present in the electrolyte, then you can say it is 1:3:1. So 1:3:1, that means 20% alumina, 30 to 60% cryolite, and 20% fluorspar is added in order to make electrolyte for the reduction of alumina. Okay, then this is another thing. So first thing we need is electrolytic cell, that means the chamber where electrolysis can be done, and the second is electrolyte, the solution that conducts electricity. And then temperature, the molten electrolyte, this electrolyte, the mixture of cryolite, alumina, and fluorspar, and then powdered coke, the temperature, the molten electrolyte is kept at 950 degrees Celsius by electrical heating. So by supplying heat through electricity, by using electricity, the chamber is heated. The chamber, the vessel, the electrolytic cell is heated, and this is heated and it is maintained at 950 degrees Celsius so that alumina melts, so that cryolite melts. Then voltage used. What is the voltage of this electrolyte? Voltage is 5 to 6 volts. A low voltage is used. So why this much low voltage is used? To avoid decomposition of the molten cryolite. So to avoid decomposition of the molten cryolite, so that the cryolite do not decompose into different components. Okay, very low voltage is used. So why very low voltage is used? In order to avoid decomposition of molten cryolite. Let's see now the process. Okay, so you can see here, this is made up of iron. I said this is made up of iron. Okay, this is made of iron. This is iron tank, and this is electrolytic cell. And it has a sloping bottom which allows molten aluminium to flow, so that it can be removed. And then these are electrodes. These are electrodes. Okay, these are electrodes. So, which electrodes we use here? Graphite. This is graphite. Carbon, graphite, anode. Carbon, graphite, anode. And this is cathode. This iron tank. Iron tank is used as cathode. And this graphite. These are graphite rods. These are graphite rods used as anode. And this is cathode. This is cathode. That means anode will have positive charge and cathode will have negative charge. So cathode is connected to negative terminal of the battery. This cathode is connected to negative terminal of the battery, and this anode is connected to positive terminal of the battery. So anode positive, cathode negative. So this total chamber, this is the total chamber, this is connected to, this is connected, say for example here is a battery. Okay. This is minus of the battery and this is plus of the battery. This is battery. And this is connected here and this is connected here. So this is connected to negative of the battery. So this is cathode. Cathode is connected to negative terminal of the battery and anode is connected to positive terminal of the battery. Hence this is negatively charged and this is positively charged. So this is carbon lining. This black you can see here, this black lining. This black lining is done by using carbon. This black lining is done by using carbon. And this is the mixture. This is the electrolyte. This electrolyte is the mixture of cryolite, fluorspar and alumina. And there is a sprinkled coke also. Coke is carbon. Is sprinkled here. So electrolyte containing cryolite, alumina and fluorspar. Then carbon lining cathode. This carbon lining. This carbon lining is cathode. Okay. Not this iron tank, but you can see the wire is ending here in the carbon lining. This carbon lining is cathode and this graphite is anode. So how many electrodes we have used in anode? 1, 2, 3, 4. 4 plates of anode made of graphite. And this carbon lining is cathode, negatively charged. Then through this molten alumina will be removed using this tab. So this is extraction of aluminium. Now, what reaction takes place in this electrolyte? These are the mixtures in electrolyte. These are the mixtures in electrolyte. Cryolite, formula Na3, Al(F)6, fluorspar, CaF2, then alumina, Al2O3. So these are the substances present in electrolyte. And this cryolite, on passing electricity, breaks into sodium ion, aluminium ion and fluoride ion. And this fluorspar, CaF2, breaks into calcium ion and chloride ion. This alumina, Al2O3, breaks into aluminium ion, then oxide ion. So how many positive ions we are getting here? In this electrolyte, how many positive ions we are getting? In this electrolyte we are getting sodium ion, then aluminium ion, then calcium ion, and any positive ion? Sodium, aluminium and calcium. Okay. So we are getting 3 types of cations. We are getting 3 types of cations in this electrolyte on passing electricity. That means without passing electricity you will not get this. When you pass electricity, then they will convert into ion. Then ionization takes place. So they convert into ions. So we are getting 3 cations, and in this one there will be the preference. That means these 3 cations can move towards cathode. These 3 cations, all of these 3 cations can move towards cathode. All 3 cations can move towards cathode. And how many anions are there? Fluoride and oxide. There are 2 types of anions, fluoride and oxide. This fluoride and oxide both can move towards anode. Okay, but there is some criteria. There is some preference criteria. So as for the preference, the metal which is lying lower in the reactivity series, the metal which is lying lower in the reactivity series will get the higher preference, will get the highest preference. So sodium, aluminium and calcium, among sodium, aluminium and calcium, which is lying low in the reactivity series? Aluminium. Aluminium is lying low in the reactivity series. So this aluminium will only get attracted towards cathode. So only aluminium will move towards cathode, because aluminium lying lower in the reactivity series will have the higher preference to move towards cathode. Higher preference to get reduced. Higher preference to get reduced. So when this aluminium moves towards cathode, okay, and among this fluorine and oxygen, which is less reactive, oxygen is less reactive. That means among fluorine and oxygen, which will be moving towards anode, oxygen will be moving towards anode. So you can see the reaction here. Among the sodium, calcium and aluminium, which will move towards cathode? Aluminium, because of the highest preference. And among fluorine and oxygen, which will be moving towards anode? Oxygen, because it is less reactive, it will have the higher preference. Okay. Then let's see what is happening. Positive ions formed in the solution are sodium, calcium and aluminium, while negative ions formed in the solution are chloride and oxide. Aluminium being lower in electrochemical series is preferentially discharged at the cathode, while oxygen at the anode. So they lie lower in the reactivity series. So less reactive metal or non-metal will get higher preference over more reactive metals and non-metals. As a result, aluminium will be moving towards cathode and oxygen will be moving towards anode. Now at cathode, what will happen? So what is the cathode used here? Inner carbon lining of the electrolytic cell. I have shown you this inner lining. This inner lining is the cathode. This inner lining is the cathode. Okay. So this inner lining is the cathode. So at cathode, what will happen? Aluminium 4Al3 plus. Aluminium is going towards cathode, and from cathode is reaching electron. Cathode is reaching electron. So it will be getting, so 1 aluminium needs how many electrons? 3. 1 aluminium needs 3 electrons. That means 4 aluminium needs 12 electrons to get reduced. So after getting 12 electrons, it will be 4Al. That means what is depositing at cathode? Aluminium is depositing at cathode. Pure aluminium is depositing at cathode. Then anode, thick rods of graphite. You can see these 4. Okay, you can see these four rods. These 4 rods. Okay, these 4 rods. These 4 rods are connected to negative to positive terminal of the battery. Hence, they are anode. So 4 rods, thick 4 rods. So thick rods of graphite are suspended into the fused electrolyte. And in this electrolyte, in this anode, which ion will be moving? Oxygen. Oxide will be moving towards anode. And oxide when moves towards anode, it is anions are rich in electron and anodes are poor, deficient in electrons. So these anions will be giving electron to anodes. These anions will be giving electrons to anode. So this 1 oxygen can give how many electrons? 2. And 6 oxygen. 6 oxygen will be losing 12 electrons in anode. As a result, in anode you will be getting oxygen. Anode will be covered by oxygen gas. So these 6 oxygen, if you break 3O plus 3O, you will be getting 3 molecules of oxygen gas. So anode will be covered by oxygen gas. Anode will be covered by oxygen gas. Anode is oxidized due to carbon monoxide, which further forms carbon dioxide. Now, anode is made up of graphite, and graphite is carbon. Anode is made up of graphite. Anode is made of graphite. Anode is made of graphite, and graphite is carbon. So, in this graphite, what is collecting? Oxygen is deposited. What is deposited in this anode? In anode, what is deposited? Oxygen is deposited at anode. That means it will get oxidized to carbon dioxide. First of all, it will convert to carbon monoxide because there will be lack of oxygen, so it will form carbon monoxide. And carbon monoxide, on further getting oxygen, will get oxidized to carbon dioxide. It will convert to carbon dioxide. It will convert to carbon dioxide. You can see here. Anode is oxidized to carbon monoxide, which further forms carbon dioxide. So carbon plus oxygen. There is not good supply of oxygen, so insufficient supply of oxygen can make carbon monoxide. So we will be getting carbon monoxide, which further undergoes oxidation to form carbon dioxide. That means by this what we can understand is graphite anode will be burning into carbon dioxide. Graphite anode will be burning into carbon dioxide. That means we need to replace graphite anode time to time. We need to replace graphite anode time to time. That's why it is designed in that way, so that it is easy to remove. So the anode has got to be replaced from time to time as it gets oxidized by the oxygen involved at the anode. So from the electrolyte, cation moves towards cathode, and among three cations, aluminium will be moving towards cathode because it has high preference, because it lies lower in the electrochemical series, reactivity series. So it can move towards cathode, and from cathode it will be getting electron, and hence it will be depositing at cathode in the form of aluminium. But in anode, oxygen will be moving, and you can see oxygen gas will be formed at anode. And since carbon can burn in presence of oxygen, and since there is less supply of oxygen, so carbon monoxide is formed first and then carbon dioxide. So anode is to be replaced from time to time. Why anode is to be replaced from time to time? Because it gets oxidized by the oxygen involved at the anode. So when the supply of alumina decreases, that means when we stop adding alumina in electrolyte, what will happen? The voltage suddenly jumps from 40 to 60 volts. That means alumina is consuming a lot of voltage. So whenever you stop supplying alumina to the electrolyte, the voltage, which was 5 to 6 volt only, will jump from 40 to 60 volts. If a bulb is attached to the apparatus, it will glow. So that means, if you happen to attach a bulb, then the apparatus, it will glow brightly, then fresh alumina is added again. That means there is indicator also. One indicator is used in the form of bulb. So whenever you can see the bulb is glowing, you have to add, that means you have to add more alumina. Whenever you can see the bulb is glowing, you have to add more alumina. So you have to add more alumina whenever you see the bulb is glowing. Why the bulb is glowing? Because the voltage is jumping from 5 to 6 volt to 40 to 60 volt. And how to know the voltage has increased? For that only bulb is attached and it glows. Whenever it glows, you have to understand that alumina in the electrolyte is finished. That means alumina has converted to aluminium. And total of alumina is over. That means you have to add aluminum again in order to continue the reduction process. Okay. So alumina, then the fresh alumina is added. Aluminium obtained is 99.8% pure. So by this electrolytic reduction, whatever aluminium you are getting at cathode is 99.8% pure. Further purification can be done by electrolysis. Further, in order to get 100% you can undergo again electrolysis. So that's all about reduction of alumina. Then, so prevents the burning of anode. That means to some extent this powder coat can reduce, okay, can prevent the burning of anode. Otherwise you will be getting tired of replacing anode again and again. So the time, that means the time of burning of anode can be increased by adding powder coat. So I think you understood why we added fluorspar and cryolite in electrolyte, why we added powder coat in electrolyte. Then uses of metals and alloys. So uses of aluminium. Why? For what we use aluminium? Being a strong, light and corrosion resistant metal, it is used in alloys. So why? It is strong, no question about it, because it is a metal, it is strong. It is light also because its specific gravity is very less. Corrosion resistant metal. Why it will not get corroded? Because whenever aluminium comes in contact with oxygen, then it forms one oxide layer. It forms oxide layer. Aluminium oxide layer will be formed. And once this layer is formed, the further oxidation of aluminium does not take place. Further oxidation of aluminium does not take place because of the protective oxide layer. So why aluminium is corrosion resistant metal? Because it can form protective oxide layer. Then it is used in alloys. Being a good conductor of electricity, it is used in the manufacture of cables for power transmission. You can see some of the naked wires for carrying high voltage electricity. The wires is made up of aluminium. Then because it is a good conductor of electricity. Then ships are made of alloys of aluminium because it is unaffected by seawater. So it is resistant towards seawater also. So ships can be made by using aluminium. Not only that, in aircraft also aluminium has a lot. It contributes a lot to aircraft industry also. Then uses of iron. Cast iron is used in drain pipes, gutter covers, weights and railings. Wrought iron means this one. Wrought iron is used in chains, horseshoes and electromagnets. Steel is used in the construction of buildings, overhead structure machinery and various alloys. Zinc. For what is zinc used? Mostly used for coating iron and steel sheets to prevent them from rusting. For making useful alloys such as brass, bronze and German silver also we use zinc. And zinc dust is used as reducing agent for many organic reactions. So in order to perform organic reactions, zinc dust is also used. Zinc compounds are used in paints, electroplast, preservatives for leather and mordants for the dyeing of textiles. Then alloys. So what is an alloy? An alloy is a homogeneous mixture of two or more metals or of one or more metals with certain non-metallic elements. That means it is a homogeneous mixture of metals to metals or metals with non-metals. It is an alloy. Alloy is a homogeneous mixture of metals and metals or metals and non-metals. So why do we make alloy? Why do we make alloy? Reasons for making alloy. So to modify appearance and color, we make alloy. To modify chemical reactivity also, we make alloy. To modify casting ability, so that we can mold it, so that we can give the shape, so that we can melt it. For that also we make alloy. To lower the melting point also, we make alloy. To increase hardness and tensile strength also, we make alloy. Iron, wrought iron is very soft, so it can be made hard by making alloy. To increase the resistance to electricity, also we can make alloy. Now here we will be learning some alloys. Okay. So what is the most important for you is for what is alloy made, reasons for alloying, then some uses of metals, and then important alloys and their uses. So this is there in your syllabus. Brass. Brass is an alloy of copper and zinc. So copper content in brass can vary from 60 to 80%, zinc 40 to 20%. If copper is 60%, then zinc has to be 40%. If copper is 80%, zinc has to be 20%. If copper is 70%, then zinc has to be 30%. And for what is brass used? For making utensils, cartridges, etc. Then bronze. For making bronze, three metals are used: zinc, copper and tin. Zinc 2%, copper 80%, tin 18%. And for what is bronze used? For making utensils, statues and coins. Then duralumin is an alloy of aluminium. Aluminium 95%, copper 4%, manganese 0.5%, magnesium 0.5%. This is very important. This composition is very important. It can be asked. So, what is an alloy of aluminium? Duralumin. And what are its composition? Aluminium 95%, copper 4%, manganese 0.5%, magnesium 0.5%, altogether 100%. So, for what is duralumin made? For making bodies of aircrafts. So, duralumin is used for making bodies of aircrafts. This is alloy of copper, this is also alloy of copper, this is alloy of aluminium, this is also alloy of aluminium. Aluminium 95%, magnesium 5% is magnesium. Magnesium and aluminium, so magnesium. For making balance beams and light instruments, magnesium is used. Then solder, it is also called fused metal. Solder is also called fused metal. It is alloy of lead. Solder is alloy of lead. So lead 50 to 40%, tin 50 to 60%. Then for soldering purposes, we use solder or fused metal. Then stainless steel is alloy of iron. Iron 73%, chromium 18%, carbon 1%, nickel 8%. So that it will not get corroded. Chromium, nickel is used. So that it remains very hard, carbon is used. Otherwise iron gets rusted very fast. So rust is prevented in stainless steel by the use of chromium and nickel, because chromium and nickel plating, the chromium and nickel do not get corroded. So the cover of chromium and nickel is done in stainless steel so that corrosion is prevented, and carbon is used in order to make steel very hard. So for making cutlery, utensils, etc. Now by this we have finished chapter number 7, that is metallurgy, and go through your reduced syllabus only in this chapter and do the exercises, refer previous year questions. This much for today. Thank you.